So here's a few news articles that I thought were interesting. This one was entertaining because it's using the same sort of script kiddie tools that we cover in these classes. So they hired, is an Israeli snoop was hired, posed as a Fox News operative, and tried to get information from a United Arab Emirates government person. And the way they attacked them was by sending them a poisoned Android app with a Metasploit shell in it. And the way they caught them was by letting them steal data that it contained a Canary token. And Canary tokens, this is what everybody should do. Canary tokens are just like email addresses or web addresses that you insert in your data that you are not using. And whenever somebody uses them, you know they've stolen your data. And on top of that, you know who they are because you get the IP address where they opened that from. So that's what they did. That's how they caught them. So that I thought was pretty entertaining, that they're using such simple tools. And you can use simple things like Metasploit shell on cell phones, probably because people aren't running antivirus frequently. It's very, on desktops, you pretty much get caught by antivirus, but most people do not run antivirus on their cell phone, although they should if it's Android. Anyway, so one of the big questions in physics is, what is the dark matter? The universe is expanding at an unexpected rate, and so there's both dark matter and dark energy, stuff they can't explain, and now they're suggesting because of a gravitational wave, they observed a black hole collision, and one of the black holes was only a little bit heavier than the sun. And it is not supposed to be possible to have black holes that small. They don't have enough mass to collapse. They'll turn into neutron stars, so they're suggesting these things were created at the Big Bang, and there may be a lot of black holes dating from the time of the Big Bang and small, and that might explain what all the dark matter is. So anyway, it's a novel idea. Now that Elon Musk has jumped into Bitcoin and Dogecoin, cryptocurrency is rapidly becoming accepted by everybody, and this is, of course, a big problem for the world because the thing that makes Bitcoin secure, and also Ethereum, is proof of work, which means all the computers have to work really hard and waste tons of energy, ridiculous amounts of energy, to run it. And the alternative is what Ethereum has been trialing for a while but hasn't really got ready yet, which is proof of stake. And this article explains proof of stake better than ones I've seen. The idea is you could not be a miner unless you donate a large amount of money, like $20,000 worth of Ethereum, and you can only mine if you've done that. And then you basically, that money is held hostage to punish you if you try to cheat and trick the blockchain. So it is an interesting idea, and it's been in pilot for a very long time. And so we'll see if they can actually get it working. Anyway, see, someone said Bitcoin farm is the next marijuana farm. Well, Bitcoin's been making real money for a long time. I'm very nervous about it because it doesn't rest on any actual product. Like NFTs, you're buying nothing. It's just a fad, like a pet rock. It has no actual value. And that troubles some people like me. But anyway, it is increasingly not troubling people, and they're getting used to these cryptocurrencies. So it looks like cryptocurrencies are going to stick around for a while, although there is no reason for them to exist, as far as I can tell. There is nothing they do that you can't do other ways, simpler and easier. But anyway, there is a wide belief that they are somehow the solution to everything, and the price keeps going up. So this I thought is pretty funny. They asked the UK government, issued a report to say, oh no, they're not discriminating against anybody. This is like the right wing in America. This is sort of why I got fed up with Rich Lowry, the editor of National Review. He published an article saying there is no systematic discrimination in America. And, you know, this is pretty ridiculous. Microsoft or Google just published a report saying, no, we don't discriminate against women, because they took women at the same level of the corporate structure to see if they get paid the same as men at the same level. They said they do. Of course, there's many fewer women at the high levels, but they didn't think of that. So anyway, this is asking the chicken to guard the fox to guard the hen house. Anyway, so Elon Musk wants to go back to a really old idea of a company town. Several people talked about this. He wants to build his own city where people have to live on housing provided by his company, then they work in his factory, then they buy all their groceries at his store, and their whole life is just controlled by him. And I don't think he's gone this far on it yet, but usually what they do is they don't pay you in real money, they pay you in scrip. In his case, it'll probably be a cryptocurrency of some kind, which is only good right there. And basically, you have a captive workforce. And the point of this is he doesn't have any problems with unions or safety regulations or taxes or anything. That's the idea. So we'll see what comes of this. I know companies are leaving America to go to other countries like Ireland, where they have lower taxes. And the Biden administration is going to try to negotiate a minimum tax deal with many nations to try to stop people from hiding their tax liability by moving the official corporate headquarters out of the nation. So this is kind of amazing. The DC Crime Lab has lost its accreditation because they incorrectly analyzed evidence and they lied about it and they covered it up and didn't fix it, and so they pulled their accreditation. So now they can't analyze any evidence until they get that fixed. There are a lot of forensic scandals. Bullet matching that was faked, DNA samples that were faked. This has happened a lot. So it really is a big deal to try to keep these forensics examiners honest. And so the Arizona Senate, forget what I thought was so great about this. This is Dominion. Can't remember why I thought this one was interesting. Anyway, this one is very interesting, however. This is called Dark Something. Dark Elements on a web page or something they call it. The point is Trump wanted to make more money, so he just changed his website where you donate so it had these extra boxes to check. And here they are. You would have this box say, make it a monthly recurring donation, pre-checked. And then when that wasn't enough, they switched to these with more pre-checked, an extra donation and a monthly donation. And then they changed it to where a monthly donation is now a weekly donation. And then they added a whole bunch of extra stuff here to trick you into not reading the last bit, up to 10 lines of extra bold text. So the end result is they tricked a whole lot of people into donating a lot more money than they meant to, which you can see by the rate of refunds. They decided to add the second free period checkbox, and then this is the rate of refunds of the Trump versus Biden campaign. Biden campaign was steady all along, not because the Democrats never did that, but because they tried some of it about a year ago and they quit because of the complaints. But the Trump campaign made a ton of money off this. And even if they had to refund it, they refunded it after the election, so they had the money during the critical time of the election. And the other thing they don't mention in this article, which came out at the time, is the reason why Trump needed this money is because his relatives, like Jared Kushner and stuff, just embezzled all the money, and Trump Jr. Anyway, Kamala Harris's evidence went missing from the evidence locker. Oh, that's nasty. Yeah, I wouldn't be surprised if there's corruption in the forensic analysis here in San Francisco, too. That sounds quite on brand. Anyway, this one I thought was very interesting. A dozen influencers created most of the anti-vax content on social media. This was also true of spam. Most of the email spam comes from a small number of individual people pumping out millions of spam things. So when you have a situation like this, then the solution, the logical solution, is law enforcement, where you find these individual people and make them stop. That's more effective than trying to build like a giant AI on Facebook to catch all the misinformation. If you have a small number of people pumping it out, then if you can just somehow stop these individual people from doing it, that would be effective. Anyway, we're struggling with this in America and having basically spinning around the drain and getting nowhere, stopping disinformation on social media. But it is really serious when it gets down to the election or the virus, when people believe a lot of lies. All right. Anyway, so here we are. Yeah, we're close enough to the official time, so we're here. I'm going to talk about recognizing C constructs in assembly, which won't take very long. It's a simple little lesson. And then I want to talk to you about .NET. I got some .NET projects, and they're a lot of fun. You'll like .NET. .NET is a lot easier to analyze than C++ compiled code. And it's really very important, especially for military and government work. They really use .NET a lot. I was in the Department of Defense bug bounty program a few years ago, and I couldn't get anywhere because everything was using .NET Nuke, and I didn't know .NET. They really love .NET out there, and I don't use Windows software very much, so I had to learn some of it, but I certainly wasn't able to contribute anything valuable to that bug bounty. Other people contributed a lot, but I didn't. Anyway, so here is the C construction assembly. Oh, that's true. I forgot to turn on my camera. Let me see if I can do that. I should be able to hit this button here. I was distracted by some other problems with my display. There we go. All right. There, we get things more or less the way they should be. All right. All right. So, if you make a program like this, and you can of course make them very easily in the Flare VM, but you can install, as we've done in some of the projects, you install Visual Basic, but you can do it with the command line tools. Just CL is the equivalent of GCC for Windows. So you can make a simple print program that just prints a couple of things, and then compile it and make an executable out of it. And then if you look at it in IDA Pro, well, let me just bring this up live. I've got it here. So here, let's see, I want a fresh one. All right. So if I go to PE, I've got hello here. So if I type .cpp, you see there it is. It does nothing but print hello. And if I run hello.exe, it prints hello. So we can examine that thing in IDA Pro. And let me bring this up and make sure it's, okay, that's pretty good. All right. So here's IDA Pro. So if I look at that print.exe and I double click it and nothing happens, there it goes. Now here it's asking you what kind of analysis to subject it to, and I'm just going to accept the default. All right, and now it's chewing on it. It's still working to analyze it. You see there's still messages going by. Now it's done, the initial auto analysis. So here I am seeing some kind of junky part of code which Microsoft Windows is doing to prepare to run that. Not what I'm interested in. So I want to view the strings. So it's view, open subviews, strings. And then right at the top I see hello. So that's the part that prints hello that I want to see. So I double click that. And now I get to the storage of the variable hello. And I double click the xref. And now I get to the function that prints hello. So what you can see is here is how hello works. You call a subroutine here, which is going to be some kind of print routine. And before you call it, you push the arguments on the stack. So here it pushes a pointer to the word hello. Here it pushes 2, and here it pushes the format string, %d, %s. So there are 3 objects on the stack. So when you jump into the print routine, it will just look on the stack, and whatever it finds there, it will print it. It has no way to know whether you properly put the right things on the stack or not. It just assumes that whatever's on the stack, you decided to use it to print. And that's what function calls look like in assembler. You push these things, and then you call a subroutine. And by the way, you push them on in reverse order. So it's hello to %d, %s in that order. It's going to expect to find them in the right order. First one, when it pops them, is going to be this one, then that one, then that one. All right, and now you've got various kinds of variables. Global variables are variables defined outside the functions. They're available to every function in your program. Local variables are the more common type, where you define them in one routine, and they use them in that routine, and when it returns from that, it throws them away. They're stored temporarily on the stack, and there's a separate stack frame created for every call to a subroutine, and when you return, it frees that memory for reuse. So if I go here, here's a global variable g equals 2, which is outside the main routine, and then there's a variable inside the main routine, I is 3. So when you go in here and print those two variables, g and I, then here it's going to move this one, dword 41b1000, that is the global variable, just pointing to an address in a data segment. And this is what a local variable looks like, just a base pointer plus a number, because it's just part of the stack here. This is the preamble that creates a stack frame. by moving the old base pointer into the stack pointer, and then it'll calculate from the base pointer, or moves the stack pointer into the base pointer. So you start a new stack frame with the base at the first available unused spot on the stack, and then you start putting variables in it. So it puts this 3 on the stack at the base pointer plus a variable, which I think is just 4, and then it puts the value of that variable into AX. That's this int I equals 3 is these two commands put together. All right. Anyway, that's the difference between global and local variables. Local variables are on the stack. Global variables are over in a data segment. And so you got arithmetic operations where you can add and subtract and multiply, and you'll see it here. So there's going to be a add here to add two things. This is going to add two local variables or addresses on the stack. This is going to subtract them. This is going to integer multiply them, and so on. Here's looks like floating point. Yeah, here's floating point multiplication down here. You can do these XMM things. Those are the floating point variables and floating point multiplication, which we're not going to be doing that much of, but it's available in the processor. And then you got an if. So here I have int I is 3, and if I is greater than 0, print this, else print that. So if you go down here, here it is moving 3 onto the stack and putting 0 on the stack. So it can have these two values, 3 and 0, to use. And then it's going to compare, well, it's going to, moves this on the stack, then it compares that value to 0. Now, if it's less than or equal, it will go one way, and if it's not less than or equal, it will go the other way. So this is what an if statement looks like. You have a comparison, and then a conditional jump, something like jump greater, jump less than equal, and then two possible ways to go, shown by this arrow. If the condition is true, you take the green path. If it's false, you take the red path. All right. And so then you have for loops, like this is a for loop in C that goes 100 times from 0 to 99. It starts at this condition. It goes until this condition is no longer true. And every time it does this to increment the variable. So it's going to print something 100 times. And so here's how it's going to look. You initialize the variable at 0. Then here, you increment the variable. Then you compare it to see if you've hit 100 yet. This is hexadecimal for 100. And if it is greater than or equal to 100, then you're done. And you jump down to 102F, which is off the bottom of the page. Otherwise, you're still in the loop, and then you print this thing. And then jump back and do it again. So all these statements are involved in making that loop. Here's arrays. You can store a bunch of data in an array in C. You make a 5-element array, which is labeled 0, 1, 2, 3, and 4, because C always starts counting at 0. You put some numbers in there, and then that's a global variable. Then in here you have some local variables, and you copy it into there. So you'll see assembly code for that. Here you are initializing. Here's the increment part. Here's the comparison part. Here you're assigning values. And so here you're assigning it to var 14. And here you're assigning, this one is on the stack. And here you're assigning it to the DA 408,000 and ECX times 4. This is in the data segment. So here we're referring to a global variable and putting data in there. Here we're referring to a local variable on the stack and putting data in there. All right. And so here's what we went through. We talked about how, of course, to find where the real user code is by going to a string and then xref. When you have a function call, you put the arguments on the stack in reverse order, and then you call the function, and it looks on the stack to find them. Global variables are in another data segment somewhere, and local are on the stack and only available to that one function while it's running, and when it returns, they're discarded. You can do arithmetic the same way, put your variable in registers and then perform add or subtract, although there are sometimes you can subtract immediate values. You don't have to have everything in registers the way you would have to have it on an ARM processor. And then in branching, you have some kind of compare with compare or test, and then some kind of conditional jump, JG, JNG, something like that. All right. So that's it for that stuff, and let's try a look at some Cahoots. And then some .NET. So what is this garbage? All right. All right, there's the one we want. Looks okay. All right. I guess that's it. All right. So what kind of variables are on the stack? Those are local. And by the way, I see a question. Yes, D-word address does mean the double word from address, the 32-bit word. Yeah. All right. All right, so what C construct gives you 3 boxes connected by arrows, like that. That's an if. Good. All right, what construct looks like several pushes followed by a call? Yep, that's how you invoke a function. All right, and what looks like this? D-word with that funny number. That's it. That's a global variable, and it is a 32-bit word starting at that address. All right. All right. All right, so I got those.